All right, let's do one more set of examples, this time with the inverse trig functions mixed in. You will have a little bit of application and some of those other problems, but they'll be the same sorts of applications and things that we've been doing. So I think just working on the shortcuts in videos is going to be the most helpful. All right, so first function, I have x cubed times arctan x, so I'm thinking about a product rule. And then I have plus, that's the biggest operation, the e to the x times the natural log of x, so I'm thinking product rule there as well. So the plus just says I'm going to tackle the two separately, so I'll start with f prime of x, and then I'll just work on the x cubed times arctan x. So I'll want the second, which is an arctan x multiplied by the derivative of the first, which is a 3x squared, and then I want to add x cubed times the derivative of arctan, which is 1 over 1 plus x squared. So that really looks pretty good. I would probably move that x cubed up into the numerator, and then I think it looks really nice. Now I have the plus that was in the middle showing up, and I need to move on to the second term, e to the x natural log x. So now we're going to take the second natural log x and multiply it by the derivative of the first. Derivative of e to the x is still e to the x, plus the first times the derivative of the second, 1 over x. And again, I would probably mush those into a single fraction, but really not a lot of simplified to do here. I don't end up with any like terms or anything I can factor, so I would leave it just like that. All right, next we start to get into some that are a little bit messier. I've got 2 to the t times arc sine of t. So I do see a product in there, but it's not the big thing. The big thing, the last operation here, is raising 2 to a power. So that means that I have an outer function 2 to the x, and my inner function is t times arc sine t. So p prime, we'll start with the shortcut for 2 to a power, which is 2 to that power, multiplied by the natural log of 2. So that's not a chain, that's just the outer function shortcut. Now I need the chain, but when I chain, it's the derivative of t times arc sine t, so I'm chaining out a product rule. So I need the arc sine t multiplied by the derivative of t, which is just 1, plus the t times the derivative of arc sine of t, which is what we're working on memorizing. It's 1 over the square root of 1 minus t squared. And again, in this one, I would push that t up into the numerator, and that's about all I would do for simplify. You could distribute the 2 to the t, this whole chunk, you could distribute that through, but I don't think it makes it any better, so I would just leave it. All right, next is a big mess, so let's be really thoughtful about where the parentheses are. So I have inverse cosine of 5z plus inverse tangent of 4 minus z, and then all of that is raised to the 27. So the last thing happening, the big operation, is raising something to the 27. That's a function type thing. So we're going to say our outer function is x to the 27, which means our first shortcut is a power rule. 27 times all the stuff in parentheses raised to the 26th. And then I've dealt with the 27, so I can ignore that now, but I need to chain out the derivative of the inner function. So the arc cosine shortcut is -1 over the square root of 1 minus x squared, but we don't have an x, we have a 5z. Okay, so that's the shortcut for, I'm going to put some parentheses, the inverse cosine. So I've dealt with the 27, I've dealt with the inverse cosine. I did not take the derivative of the 5z, so I'm going to chain out a 5, and I'll just move that into the numerator. And then I have the plus, and I need an arctan shortcut, which is 1 over 1 plus x squared, but we don't have an x, we have a 4 minus z. And then once again, I've taken the derivative of the inverse tangent, but I haven't taken the derivative of the inner 4 minus z. So the derivative there is -1, and I'll chain that out, and I'll just multiply that into the top as well. Or you could change the sign in the middle to a minus. So this has chains inside of a chain rule. So we're not just chaining out and chaining out and chaining out. In fact, that's something to be careful of. Some people want to multiply the 5 and the -1 out here, but they're not chains on everything. They're just chains on their little piece of the derivative. So the 5 only hooks to this fraction and the -1 only hooks to this fraction. Okay, next one is cosine of arcsine of y. And actually, we did some of this fractions work. You could rewrite that so that there weren't any trig functions, but trig functions are fairly easy to take the derivative of, so I don't think we need to. So this is inner function arcsine y, outer function cosine. We'll start with the derivative of cosine, which is minus sine. And then we leave the inner function alone in this step. Now we've dealt with the cosine, we need to chain out the derivative of arcsine, which is 1 over the square root of 1 minus y squared. So this is good, we're done taking derivatives, but I do want you to notice that sine and arcsine are inverses. So if you take the sine of the arcsine of y, you just get y. And then I'm going to go ahead and move that negative and that y into the numerator and say my final answer is -y over the square root of 1 minus y squared. All right, next, natural log of sine squared of v plus 1. So m prime is, let's see, natural log is the outer function, so we'll start with that shortcut. The derivative of natural log of stuff is 1 over stuff. And then we're done with the natural log, so we can hide that for ourselves. We need to chain out the derivative of sine squared v, so that needs to be multiplied. I can just multiply it into the numerator. This one is a little bit tricky, as you saw in the last section. Remember that what that really means is sine of v squared. So that has an outer function, so this is another chain, outer function of x squared, so we'll do a power rule. 2 times sine to the 1, and then we're not done. Now we've dealt with the squared, we still need to deal with the sine v. The derivative of sine v is cosine v. I switched to x here, but it should be a v still. And then plus 1, but the derivative of 1 is 0, so this is really it. That's our whole derivative. Okay, last one, we have a quotient rule inside of a chain rule. So we're going to start with the outer function arctan, g prime of w. Okay, and the shortcut for arctan is 1 over 1 plus stuff squared. And for us, the stuff is natural log of w over 1 plus w squared. And then we need to chain out the derivative of the inside function. So we've dealt with arctan, but we haven't dealt with the natural log w over 1 plus w squared. And as soon as you hit something other than a composition, so when I look at that, I say it's a quotient, you know that that's your last step. There might be things within the quotient rule, there might be chains or products or other quotients, but there won't be anything that chains out after that. So the bottom is a 1 plus w squared squared. The top is a 1 plus w squared times 1 over w minus the top, natural log w, times the derivative of the bottom, which is 2w. Okay, I'm going to work on cleaning this up just a little. In fact, we can maybe clean this one up kind of a lot. I better not write too big. I'm noticing some things. One is that the natural log of w over 1 plus w squared, you can split that up. You can make it the top squared and the bottom squared. And the reason I think that's interesting is if you look, we're multiplying two fractions. If we multiply those denominators together, we'll get a little bit of cancellation that happens. I'm also seeing some things on the top. One is that I can distribute a 1 over w through, and the other is that when I multiply the numerators of the two fractions together, one of them is just 1, so I'll just get that second numerator. So when I start that distribute, I get a 1 over w, and then when I multiply 1 over w by w squared, I just get plus w. And then I get minus 2w natural log w. You don't have to rearrange the order there, but I'm just doing it to avoid that temptation of trying to multiply the 2w into the natural log. You can't just mush things inside of functions. Okay, so on the bottom, what I'm looking at here is distributing this to the 1 and to the fraction. So when I distribute it to the 1, I get 1 plus w squared squared, and when I distributed it to the fraction, the 1 plus w squared cancels, and I get natural log of w squared. And this is pretty good. I just see one more thing that I need to deal with, and that's fractions and fractions. So I'm going to multiply top and bottom by a w, and then I think I'm done. So that first multiplication gives me a 1. The next one gives me a w squared. And the last one gives me minus 2w squared natural log w. And in the bottom, you could just put a set of parentheses with the w, or you can distribute that w through 1 plus w squared squared times w plus w times the natural log w squared. I would not multiply out the 1 plus w squared squared. I don't see that doing anything to help me simplify this fraction. So I think just like that is fine for this one. Okay, so really work on memorizing those shortcuts and really take advantage of the practice with all of your old shortcuts that's mixed into this section. This is kind of like the grand finale of shortcuts and putting them all together before we move into implicit.